Hello everyone. In this video, going to share about wrapper classes in Java. What are wrapper classes? Classes whose objects wraps or contains primitive data types are called wrapper classes in Java. The wrapper classes provide the ability to convert a primitive value into an object and vice versa. Whenever an object is created to a wrapper class can store primitive data types. That is, we can wrap a primitive value into a wrapper class object. The java.lang built-in Java package contains 8 wrapper classes, each one for the available primitive data types. Why do we need wrapper classes in Java? To maintain object-oriented consistency. Object orientation is one of the most important features of Java. The JDK contains a bundle of built-in libraries, APIs, and frameworks that rely on objects. Primitive data types are not objects, and this deviates from its consistency. To maintain consistency in programming, wrapper classes are needed to fill up the gap created by primitive data types by enabling the ability to treat primitive values as objects. Ability to modify method argument value. Java supports only call by value. We won't be able to change the original value of the method arguments passed as primitive values. With the wrapper classes, we can convert primitive value to object and thus have the ability to change the original value for serialization and synchronization. We will see both these concepts in detail on later videos of this tutorial. For now, remember, synchronization only works with objects in multithreading, and to perform serialization, we need objects. Hence, wrapper classes are needed as we can't achieve them through primitive data types alone, collection frameworks, and generics. The data structures in collection frameworks can only store objects, not primitive data types. Generics provide type safety and works only with objects. Advantages. Cloning. With wrapper classes, we will be able to clone the objects of it. Only objects can be cloned. Nullability. Primitive data types cannot be null as they always have a value. Wrapper classes allows null value initialization that can be hugely advantageous in a variety of programming contexts. Additional functionalities offers additional functionality through their methods. We can easily perform operation and conversions through those methods. Some example methods are toString, int value, equals, etc. Flexibility. By wrapping primitive data types that enables consistency and with additional capabilities, wrapper classes improve flexibility. While wrapper classes are extremely useful, they are not without disadvantages. More memory utilization, additional code on autoboxing and unboxing are some of them. Let's look at an example to understand in detail. I had created a class demo wrapper classes and inside the main method creating objects with integer wrapper class. For the first object using integer wrapper class static method parse int. To the parse int method passing string value 1. This is just one of the ways of creating objects for integer class. We can create object through method shown here for object 2 and 3 with value of method or by directly assigning an int value and many other ways. If you want to know what are the methods available in the integer class, in the IDE type integer and a dot. It will show all the available methods of that class. Now you have the method name and parameter list, but you don't know what that does. To understand what a method does, you can go to the wrapper class and see the code of the integer wrapper class. For beginners to understand what the method does, I recommend to read the Java docs command that are available on top of every method. Then just creating an object with a double wrapper class. For each of the wrapper class, we can create objects similarly to those wrapper class methods. In older version of Java, we can use new keyword for wrapper class. Like this, new integer of parameterized constructor. This method has been duplicated with newer versions as you can see. Printing all the wrapper class objects and then using additional methods to showcase how they work. Let's take compare to method. As you can see, compares two integer objects numerically. Params, another integer, the integer to be compared. Returns the value 0 if the integer is equal to the argument integer. A value less than 0 if the integer is numerically less than the argument integer, and a value greater than 0 if this integer is numerically greater than the argument integer. So here we will get -1 as the result. Let's execute and verify. Output is printed as expected. We have auto boxing and unboxing and the custom wrapper classes concepts that are related to this. We will look at them in the next video. Thank you.